Hello and welcome students to Make Pro Classes, my official YouTube channel. Myself Piraj Mujumdar, Assistant Professor of Mechanical Engineering Department of Greater Kolkata College of Engineering and Management under GIS Group, welcomes you to new session, a new subject that is Advanced Welding Technology series. I am going to cover the detailed syllabus day by day in my YouTube channel, that is Make Pro Classes. Here you will find my contact number 9433465217. For any query you can contact me, or you can email me at pirasir@gmail.com. You can also connect me through Facebook page, which is also known as Make Pro Classes, that is similar to the name of my official YouTube channel. So let us start today's class. So Advanced Welding Technology, code is ME704B, contact hours is 3 lecture, credit is 3. So you can see over here, this is the whole syllabus for the Advanced Welding Technology subject, and we will be covering all the modules day by day. So you can see there are all total 7 modules. So we will start from module 1, that is review of welding processes and joint design. So here you can see first module, that is a review of welding processes, joint design. Okay, so now let us start the class. So today our first class on advanced welding technology, and I hope you have already know and might have heard this welding term. It is a very common term and sometimes also known as the fabrication process, and this actually fabrication process includes various of the joining processes like welding, rebating, brazing, soldering, and many more. Okay, so welding is a very versatile process used in various industries, and being widely used and very popular also, and having a joining of material in different purposes. Okay, so in short I can say joining two or more elements to make a single part is termed as fabrication process. A fairly large number of industrial components are made by this fabrication process. Okay, some of them are widely used in aircraft, ship bodies, bridges, building process, welded machine frames, sheet metals, and many more are there. Okay, so there are wide use of this fabrication process. The fabrication is often the most economical method and relies on raw material obtained from one of the primary manufacturing processes such as rolling and extrusion. Okay, so generally a manufacturing process is classified into primary manufacturing process and secondary manufacturing process. In primary manufacturing process, what we are drilling, we are getting the raw material in a form of iron ore. Say, let us consider iron. So when you are considering iron as your raw material, the ore is the raw material for the primary manufacturing process. So we are getting hematite or magnetite, then we are having the operations going on with this blast furnace. We are getting the pig iron out of it. Then we are processing it and we are producing different types of steel as well as cast irons also from cupella. Now after this, we are applying the primary manufacturing process, so ingots, blooms, billets are, you can say, as the raw materials for the primary manufacturing process. Okay, so in primary manufacturing process we are having the say if you are considering iron, then or you can also consider any non-ferrous materials also, but the main purpose is that we are getting that the raw material as a form of ingots or blooms or billets as per use. Okay, then that particular this material is being processed in, say, using casting process or forging process or different metal forming process. Okay, so whether we are using the sheet metal operations, or we are using rolling operation, or we are using the extrusion operation, so whatever may be the process, that process is known as the primary manufacturing process. And after that we are using this fabrication process to join the materials, that is known as the secondary manufacturing process. Sometimes we can also consider the metal cutting process, that is shaping or drilling or milling or any operations coming out of this lathe can also be termed as the secondary. They are actually coming under the heading of secondary manufacturing process. So you can easily visualize that primary manufacturing process mainly deals with the metal forming process such as rolling, extrusion, forging, and the secondary manufacturing process mainly deals with the metal cutting, fabrication process mainly. Okay, now various fabrication process are there as well, like the mechanical joining of bolts, screws, nuts, rebates. Okay, so there are classification of this joining processes. If you consider welding, then it is a permanent joint, and if you consider rebate, it is somewhat semi-permanent, you can say. And if you consider the these fasteners, that is the bolts, screws, you can consider this as a temporary joints. Okay, so when you can easily remove without giving any harm to the parent material or the sheets, joint sheets, uh, they are known as temporary joints. But while separating, if you damage the sheets, say in case of welding, or sometimes also in case of riveting, when you try to apply force to separate the two joint materials out of the welding process, then you certainly would damage the two different this parent materials. Okay, so that's why this welding process is known as a permanent process, as you cannot easily remove this joint by means any other means of mechanical forces as well. Okay, now there are also some other processes like adhesive bonding. Okay, they are using synthetic glues such as epoxy resins. Next comes the welding, brazing, soldering as well. Okay, now the choices of particular fabrication method depends on number of factors pertaining to the joint, such as type of assembly, as I earlier told you, whether it is a permanent or semi-permanent or temporary. Next is your what is your material actually you are being joined, that is the steels, that is a ferrous or non-ferrous. Okay, like aluminum, similar or dissimilar metals. Okay, so these are the different factors on which the choice of a particular fabrication methods depends actually. Okay. Next is also there is economy, how much you are going to spend for this particular joining process. So economy achieved is also one of the factors choosing the particular fabrication method. Next is the type of service required, such as assembly subject to heavy loading, whether what is the purpose of joining, whether you are going to this use this particular joint material that is that should be subject to heavy loading or impact loading or high temperatures, etc. So depending on the usage, as well as various atmospheric as well as circumstantial situations, the choice of fabrication methods also varies. Okay, now joining obtained by bolts and screws is temporary in nature and can be disassembled whenever necessary. Now rebates are semi-permanent fastening devices, and the joint can be separated only by destroying the rebate without harming the parent materials. Okay, so this type of mechanical fastening involves making holes in mating parts, which are to be properly accounted for at the design stage, as you can say. Okay, now coming to the adhesive bonding, you can say adhesive bonding doesn't disfigure the the joining parts, but would generally have less strength than the mechanical fasteners as well. Okay, but adhesive bonding helps in joining awkward shaped parts or thin sheets, which may not lend themselves to mechanical fastening. Similarly, metals and non-metals can also be best joined by adhesive bonding, as in case of automobile brake shoe linings also. Also, the sandwich structure construction for damping structural vibration relies to the damping capability of the adhesive also. Okay, now adhesives are capable of providing the necessary strength to withstand the applied loads for some applications as well. And the most commonly used adhesives are classified as thermosetting resins, thermoplastic resins, silicone resins, and elastomers. Out of this, the elastomers, which comprise synthetic and natural rubbers, are elastic in nature and therefore cannot be used for structural applications, since they lack the necessary rigidity. However, they can be mixed with the thermosetting resins to reduce the brittleness and provide the toughness for shock resistance as well. Okay, now the joint for adhesive application should be properly chosen to provide the necessary cleanliness and the required surface roughness. The type of adhesive chosen should take into account the geometry of the joint, the type of load application, working conditions such as temperature, as I earlier told you, and also the humidity. Okay. Now the adhesives are normally applied by either brushing or spraying. The adhesive joint should be cured after assembly by simple air drying or more commonly using baking process. The temperature and time control during the curing process is vital for the development of proper strength as well. Now welding, by contrast to the above, this fabrication technique, is a metallurgical fusion process where the metal being melted. Actually, the parent metal is melted. Here, the interface of the two joints, the two parts to be joined, is brought to a temperature above the melting point and then allowed to solidify so that a permanent joining takes place. Now, because of the permanent nature of the joint and the strength being equal or to, or sometimes greater than that of the parent material, makes welding one of the most extensively used fabrication method. As I earlier told you, it is the most widely used and most popular method in industry for joining. So welding is not only used for making structure but also for repair work such as the joining of broken castings as well. Now products obtained by the process of welding are called weldments. So now one more thing, the abbreviations we are going to learn in our later classes would be given by the American, I'll just write it down for you. It will be given by American AWS. Okay, so American Welding Society, AWS. Okay, now let us consider the slides. So coming to the definition, it is written over here as the localized joining of materials with or without the use of filler, and also with or without the application of pressure. Now I must add one thing. It is joining of similar or dissimilar metal, you can say, with or without the use of filler materials, that is the electrodes or rods simply, also with or without the application of pressure, as well as with or without the application of heat as well. So if you consider the actual definition of welding, it is a joining process of similar or dissimilar metal with or without the application of heat, with or without the application of pressure, and with or without the application of filler material or electrode or simply the rods. That is the whole definition of a welding. There is one more thing written over here, that is as the word definition of welding as bringing to perfectly smooth and clean. So this is also very important. First you have to make the two parent materials as smooth and clean. So you have to clean the surface in order to have a good weld structure. To intimate contact, which is an atomic distance. Now this distance is very short, that's why it is known as atomic distance. Indeed, between the two is known as welding. Okay. Now welding, it is a material joining process, two parts connected at their contacting surfaces by suitable heat or pressure. Many welding processes are accomplished by heat alone, some others by heat and pressure, and some with pressure alone. Now in some welding operations, a filler material, that is, I told you, that is an electrode or simply a rod. In industry they are just simply saying this electrode as a simple rod. Okay. Now welding operation usually applied to metals but also used for plastics as well. Now coming to the welding joint terminology, there is a typical diagram. Here you can see this is the parent metal, this is the parent metal, and this is the welded metal. Okay. Now the upper portion is known as the face, the lower portion is known as the toe. So here you can see weld face, this is the face toe, this is the root toe, this is the root. Okay. Now heat affected zone, that is very important, H. So I'll just write it as HAZ. This is very important, and this portion is the heat affected zone. So here you can see the portion surrounding the welding is known as the heat affected zone, where microstructural changes takes place due to the development of high temperature over here. So this region is the has. Okay, so it is very important as well. Now here you can see the upper side from the lower side, the thickness, this is the total length, you can say, for the welded metal. It is known as weld metal thickness. Okay, So this is a typical diagram of welding structure. Now here I have taken chosen another diagram for giving a clear idea of what actually welding setup looks like. So this is the parent material, as you can see. Here is the electrical arc, as you can see over here. A filler rod is this one. Here is the shielding gas. Generally argon, helium, carbon dioxide are generally used as shielding gases to protect the material being oxidized by the atmospheric pressure, this oxygen. Okay, so in order to make the atmosphere inert, we are using the shielding gas. Okay, now this is the conductive. This is a picture of actually the TIG welding. We will generally learn after some classes. Actually, TIG, tungsten inert gas welding. Here you can see the tungsten electrode, which is non-consumable type. I will come in later classes what actually is function mechanisms of this particular TIG welding. Just to give you a clear idea how the welding actually goes on. So here GTAW, there is the gas tungsten arc welding. Head is given over here. This is the power coming out of here, and this is the weld base. This is the electrical typical diagram showing the different the setup of a particular welding process. Next is very important, the welding joints. So these are the most common, this butt and lap joint. You might have heard in workshops. So actually what happens in butt joint, they are being placed like this one, okay, side by side, and welding is here only. Okay, so that is the butt joint. But if you consider lap joint, and it goes on overlapping somewhat like this one. Okay, so here this welding, and here is the welding. So this is the this view is this one, the front view. You can see over here is given over here. Okay, so here you can see when the two parent materials are being overlapped. So here you can see these are being overlapped. So this particular joint is known as the lap joint. So these are two very common joint used in welding, during welding. The one is the butt joint, next is the lap joint. Next, look at this particular picture. This is the corner joint. Here is the this parent material, and here is also the parent material, and they are being joined in the corner. So you can see over here. So this is a typical corner joint you can find over here. Now coming to edge joint, the parent materials are placed like this one, side by side, and the metal is deposited in the edge. So that's why it is known as edge joint. Now coming to the T joint, also somewhat the fillet, they used to say, the fillet joint. So here you can see this look like a T, inverted T. So T is this one and inverted T is this one. Okay, sorry. So T is this one and inverted T is this one. Actually, so this one. Okay, so here you can see this is also sometimes known as the fillet. So these are the parent metals, and welding is performed. So you can see this sides and this sides. So this is the typical T joint. So these all joints are very important, and you must take a note somewhere, and you must keep in mind these are the most commonly used welding joints. Now coming to the groove formation, this is square when there is no groove. This is a closed square when there the space is very less between the two parent materials. Now in order to have a strong joint, we are generally beveling one side and keeping the other side as intact. It is known as single bevel. And if you are beveling like this one, it is known as J, in a shape similar to that of J. So this is the single J. And when you are having a greater strength, you are wanting in a need of greater strength, So you are giving double bevel, that is the double bevel. So you can see greater material will be deposited over here. So here greater material will be deposited over here. So it will give you more strength. Now coming to the double J. So this also more strength, for to provide more strength, double J is used. Okay. Now coming to this particular single V, these are being widely used actually. In workshop you might have seen, we are used to we will actually this grooves are being produced before the welding process with the help of the file. So we have to file the two parent materials, we have to clean properly so that metal being properly deposited over here, and it will be a stronger joint, weld joint. So this is the most common, single V joint is the most common. Now coming to single U. Now single U is somewhat harder, stronger than this single V joint. Okay. Now coming to the double V. Now double V, you can see over here more materials are deposited. So depending on the strength, depending on the thickness of the materials, the groups are particularly constructed. Now coming to the W, double U is the most stronger among all these groups. So you must keep in mind that double U is the most commonly used welding joints to provide stronger strength, and the most commonly used is the single V joint. Okay. Now there are such symbols as you can see over here. These are going to be very important for your exam purposes and also for your competitive examinations as well. So for square butt, this is very important. This symbol is very important. Square butt you have to remember. Now here you will find the typical structure of the square butt. Now coming to the square V butt. So this is the square V butt and the symbol is this one. So these all symbols are coming out of the American Welding Society, AWS. This is square V butt with broad root face, as you can see over here. This one looks like, the symbol looks like of Y. Previously it was V, that is a single V butt. Next is your single bevel butt. This one is single bevel butt. Next is your single bevel butt with broad root face. This one. So this. Next is your single U butt. So this is a single U butt. Similarly of U. Next is single J butt. So J is this one. So you must keep in mind that this is most popular question coming out of this welding joints in different examinations, competitive examinations. So you keep in mind that square butt, this one, this symbol is very important. Okay. So I will just end up to discuss over here. Next we will learn some again some symbols of welding joints in our next classes. So that's all for today. Hope you have enjoyed today's session. Thank you for watching.